All right, let's get started. Our first talk on this here in the Netherlands, sunny, beautiful morning, is going to be by Dorothea Pregla with colleagues Paula Lissón, Shravan Vasishth, Burchert, and Nicole Stadie. And her talk is entitled Adaptation to Complex Sentences in People with Aphasia and Language Unimpaired Adults in German. So take it away, Dorothea.
Thank you. Okay, so this talk will be about sentence comprehension in people with aphasia. Aphasia is a language impairment due to a brain disorder. A typical example for a complex sentence is an object relative clause, such as, here is the tiger that the donkey comforts. Such a sentence is often more difficult to process than a subject relative clause, such as, here is the tiger that comforts the donkey. One difference between those two sentences is their word order, which is canonical in the subject relative clause and non-canonical in the object relative clause, because the word order differs from the basic word order in English. And therefore, the difference between subject and object relative clauses is also referred to as canonicity effect. Canonicity effects have been studied intensely in English, but also in other languages such as German, which will be the focus of this talk. What has been studied less often, though, is how canonicity effects change over time. For language unimpaired adults, Wells and colleagues found that after 4 sessions of exposure to subject and object relative clauses, canonicity effects decreased. With respect to people with aphasia, Mack and colleagues found that there was no interaction between sentence type and test session. However, these authors only exposed their participants twice to the canonical and non-canonical sentences, and therefore it's currently not clear whether people with aphasia do not show a reduction in canonicity effects or whether the number of exposures was simply not high enough to see a reduction in canonicity effects. And this is an interesting question because it has been suggested that one reason for the processing difficulties in people with aphasia could be an inflexibility in adjusting their expectations about the upcoming sentence structure to the actual input. And therefore, the missing reduction in canonicity effects could be an expression of an inflexibility. We carried out a large project in which we investigated sentence comprehension in people with aphasia by developing computational models and a large database of sentence comprehension performance in aphasia. And we think that this database might be suited to investigate the question whether people with aphasia can show reductions in canonicity effects because we expose the same participants multiple times to the same sentences. And therefore, the focus of this talk will be to evaluate the variability in canonicity effects between test phases. However, I would like to point out that when we designed the database, we did not have any specific predictions on how this variability would look like in the people with aphasia. This is an overview of the database. It includes 50 language unimpaired adults and 21 people with aphasia that had to comprehend declarative sentences and relative clauses, among other sentence structures. Participants had to carry out 3 tasks, 2 versions of a sentence picture matching task and an object manipulation task. The first sentence picture matching task was combined with visual world eye tracking to track the eye movements while the participants heard the sentences. And in the second sentence picture matching task, participants had the possibility to praise themselves through the sentence and to determine the speed of the sentence presentation. All tasks were carried out twice in a test phase and in a retest phase. And here you can see the design. Participants entered the experiment and had to complete all sentences of the database in the first task in the first session. Then they were re-invited after 1 week to complete the comprehension of the exact same sentences a second time in the second task. And then they were exposed a third time to all sentences in the third task in the third session. Then there was a break of approximately 2 months. And afterwards, all tasks were repeated. which means that participants were exposed a total of 6 times to all sentences. And here's an example for a sentence, which is, hier tröstet der Tiger den Esel, or in English, here the tiger comforts the donkey. And in the sentence picture matching task, participants saw 2 pictures while they listened to the sentence, and afterwards they had to choose the picture that best matched the sentence meaning. The database included canonical sentences in which the subject preceded the object, but it also included non-canonical sentences in which the object preceded the subject. And the word order is signaled by the case marking of the determiner in German. And these were our predictions. First of all, we predicted to see a canonicity effect. And one explanation for this effect in German would be that canonical sentences are much more frequent than non-canonical sentences. Furthermore, we predicted to see test-retest variability, and one might predict that there are differences in the changes of canonicity effects over time between our 2 participant groups. We use Bayesian hierarchical linear mixed models to analyze our data, and in the upcoming slides, I'm going to show you the mean and the 95% credible interval of the estimated effects. The 95% credible interval is the range of plausible values given the data and the model that you used. I will show you results for the dependent variables accuracy, response times, and eye movements, and the independent variables were participant group, canonicity, and test phase. And for the predictor test phase, we pooled the data of the 3 tasks. And these were our results. First of all, we predicted to see a canonicity effect, and our results were consistent with these predictions, both for the language unimpaired participants and the people with aphasia, and in the declarative sentences and in the relative clauses. Next, we found an effect of test phase because there were faster response times and higher accuracies in the retest phase. And this was also the case for both participant groups. Importantly, we found an interaction between participant group, test phase, and canonicity effect, both in the response times and in the accuracy. And this seems to suggest that there are differences in the canonicity effects between the 2 test phases, but that these differences are different between our 2 participant groups. And in the upcoming slides, I would like to focus on this 3-way interaction a little bit more closely, because that's the interesting part which could tell us more about whether people with aphasia show the same reductions in canonicity effects as language unimpaired adults. So let's first of all look at the 2-way interaction between test phase and canonicity effect nested under participant group. Here I show you the results of the Bayesian models. In dark blue, you see the mean of the estimated effects, and the borders of these light blue areas here represent the 95% credible interval. Let's first start with the plot for the accuracy. Here I show you the difference in canonicity effects between the test phase and the retest phase. When the distribution is shifted in the negative space, this means that there is an decrease in the canonicity effect in the retest phase. Let's first of all look at the language unimpaired adults. Here we see indeed a shift of the distribution in the negative space, which seems to suggest that the canonicity effect decreased in the retest phase. Let's now look at the distribution for our people with aphasia. Here we see a shift of the distribution in the positive space, which seems to suggest that the canonicity effect increased in the retest phase. Let's next look at the estimates for the response times. With respect to our language unimpaired adults, we see a similar result as for the accuracy, namely the distribution is shifted in the negative space, suggesting that the canonicity effect decreased in the retest. With respect to our people with aphasia, we see a distribution that is very wide and includes both positive and negative values, and therefore this result is inconclusive with respect to the question whether canonicity effect decreased. So it seems to be indeed the case that participants without a language impairment show a reduction of the canonicity effects over time. However, we were also interested in whether we can see this reduction in each of the separate tasks that were carried out. And this is what you can see here. Let's first of all look at the accuracy. Here you can see the estimate for the canonicity effect in each of our 3 response times separately for each of the test phases. Let's first of all look at the estimate for the object manipulation task. We see that the distribution is shifted more in the positive space in the first test phase, and then it shifts towards 0 in the second test phase, suggesting that there is a decrease of the canonicity effect in the second test phase. A similar shift towards 0 is also visible in the 2 sentence picture matching task. And similarly, when we look at the response time, we see a shift towards 0 in both sentence picture matching tasks. So when we look at all of these results together, it seems that there are systematic changes in the canonicity effects between the test and the retest. Now, these are the results for the group level, and we were also interested in whether these results are driven by single participants acting in a specific way. And this is what I show you here. So these are the random effects of each of our participants. On the x-axis, you can see all of the 50 participants in the database. And on the y-axis, you can see the estimated canonicity effects. The black lines represent the estimate for the test phase, and the yellow lines represent the estimates for the retest phase. So when we compare the estimates in canonicity effect between the 2 test phases, we see a shift towards 0. And importantly, we see this shift across the different participants in the data set. Now, how does this look like for our people with aphasia? Remember, when we looked at the 2-way interaction, there seemed to be an increase in the canonicity effects and accuracy and inconclusive result in the response times. How does this look like when we look at each separate task? So this is what you can see here. Let's first start with the accuracy again, and with the estimated canonicity effect for the object manipulation task. We see that the estimate shifts away from 0 in the second test phase, which seems to suggest that there is an increase in the canonicity effect between the test and the retest. A similar shift away from 0 is also visible in one of the sentence picture matching tasks, while the estimates are almost identical for the second sentence picture matching task. And when we look at the response times, we see a shift of the distribution towards 0 in the first sentence picture matching task and a shift away from 0 in the second sentence picture matching task. So when we look at all of these results together, there seem to be more unsystematic changes in the canonicity effects in the people with aphasia in comparison to our language unimpaired adults. And how does this look like when we consider each of our people with aphasia separately? This is what you can see here. On the x-axis, you can see the 21 people with aphasia, and on the y-axis, you can see their estimates for the canonicity effect, in black for the test phase and in yellow for the retest phase. So when we look, for example, at participant 21, we can see that there is a shift away from 0 in the retest phase in the canonicity effect. However, for example, when we look at participant 15, we see a shift towards 0 in the retest phase. So there seem to be more unsystematic changes also at the individual level between our participants. And when we compare the 3 different tasks, we can also see that the changes are more unsystematic within the participants. Finally, let's take a look at the online results that we got in our visual word eye tracking paradigm. Here you can see on the x-axis the time since the onset of the critical word in the input, and the critical word was the determiner, which had a specific case marking that signaled the word order. On the y-axis, you can see the proportion of looks to the target picture, and both participant groups start with about 50% looks to the target picture in the beginning, and that would be expected because at the beginning, the people do not yet know whether the target picture is the picture on the right or the left side, and therefore they look at each picture in equal proportions. However, shortly after the onset of the critical word, language unimpaired participants start to fixate the target picture more often than the distractor picture. And when we compare the blue lines that represent the canonical sentences with the orange lines that represent the non-canonical sentences, we see a steeper slope in the canonical sentences. And this would be expected because canonical sentences should be more easy to process than non-canonical sentences. We can also compare the solid lines that represent the fixations in the test phase and the dashed lines, which represent the fixation patterns of the retest phase. And here we can see steeper slopes in the retest phase. And this is especially the case for the non-canonical sentences, which seems to suggest that people get more efficient in processing these sentences in the retest phase. But what happens with the people with aphasia? As I said, they also start out with 50% looks to the target picture in the beginning. And then we see some increase in the looks to the target pictures. I would like to note that those are only the correct trials that you can see here. So the trials in which people selected the correct picture in the end. We can also see that there is much more noise and much more overlap in the estimates for the different conditions. And importantly, we see that the dashed lines, which represent the retest phase, increase more slowly than the solid lines. So people with aphasia do not seem to get as efficient as the language unimpaired adults in the retest phase. So to sum up, there was some support for the presence of canonicity effects in both of our participant groups. And we also saw some support for the presence of a better performance in the retest phase in both groups. And we think that this is due to an increased task familiarity, because when participants were invited a second time, they already knew how the procedure would be, and therefore they answered a little bit faster and more accurate in the retest. But we also saw some support for the presence of a difference between the participant groups, namely in the changes of canonicity effects. With respect to our language unimpaired adults, we think that our results show some adaptation to the complex sentences because there was a systematic decrease in the canonicity effects. However, people with aphasia seem to have difficulties adapting to complex sentences because the changes in canonicity effects were more unsystematic. And this conclusion is in line with an earlier conclusion of Warren and colleagues. And on this slide, I would like to show you one explanation for why we see those differences between our two participant groups. Both participant groups start, when they enter the experiment, with a high expectation of canonical sentences. However, after getting exposed multiple times to non-canonical sentences, language unimpaired participants seem to start expecting non-canonical sentences more often. And therefore, also the processing difficulties for non-canonical sentences seem to decrease over time. People with aphasia also start with a high expectation of canonical sentences. However, they seem to have difficulties adapting or changing their expectations even after getting multiple times exposed to non-canonical sentences, and therefore also the processing difficulties for non-canonical sentences remain high. And I would like to end this talk with some implications for modeling and treatment. With respect to connectionist models, there arises an interesting question, which is how one could model the lack of adaptation. Can it be that you can model the lack of adaptation in people with aphasia just by increasing the noise in the model? Or would one have to assume a certain defect? And with respect to treatment, it seems that people with aphasia might not be able to improve their sentence processing of syntactically complex sentences just by getting exposed repeatedly to those sentences. At least this was not the case after 4 sessions of exposure to these sentences. And therefore, our results speak more for impairment-specific intervention protocols. And with these considerations, I would like to end this talk. I would like to thank you for your attention. And if you like this talk, you should also go to the short talk by my colleague Paula Lissón on Saturday.